10 minutes on 6.1, confidence intervals for the population mean. Use your pause button. I'm going to move quick here. Number 4, key question. 95% confidence interval for the population mean using the random sample. The confidence interval is 24.9 to 31.5. Is the probability that mu is in this interval 0.95? Explain. This is a key concept on this. The answer is no, it is not. The confidence interval is the mean is either in the interval or it is not. We usually don't know that. So it's in the interval or it is not. There's no probability about it. This means about 95 of 100 intervals constructed this way would actually contain the mean. So that's a key concept. It's not a probability. It just means 95 times out of 100 about it would work this way. Problem number 6. Number 6 is like 5 and 7. You're going to be doing this on almost every problem. There are some regular numbers we use all the time that they show in the chapter you got to know. First off, alpha equals 1 minus c. That comes up. This is our c right here is our 0.85. Because of the symmetry, we have this alpha over 2 because it's not going to be 0.85 there. It's going to be 0.15 over 2, which is 0.075. 0.075 is going to be the area over here. Z alpha over 2, negative Z alpha over 2, Z alpha over 2 are opposites because of the symmetry. So I'm going to look that up on my table, that 0.075 value. I'm going to look that up on my table over here, 0.075. Right there, 0.0749. And let's see what that is, negative 0.144. So that's equal to negative 1.44. Actually, I should just use the positive on that. We always just assume the positive value. So we got 1.44 for the positive, negative 1.44 for the negative. I forgot, number 6, you got to do 5 to 8. Number 18 I'm going to do, you have to do 17 and 19. Now the key concept is over here, recognizing these numbers. The bigger the confidence level, the wider the interval. Number 18 is the C equals 0.90. Right there. So I'm going to notice that's the second smallest one. It should be the second smallest interval. The way they have these lined up nice, that makes it look like D down here. So D is going to be the interval for number 18. Second smallest confidence level, second smallest interval. Number 23, I got this Z critical value right here, the 2.575. That is on page 299 in your book. In the study tip on the side, those are 3 common critical values you should memorize. Other ones you have to look up like we did in number 18. So I got a formula. Our confidence interval is the mean plus or minus the margin of error, E, which is the mean plus or minus the Z critical times the standard deviation over the square root of n. Fill in your numbers. So I got my numbers in. Now it's time to put it in the calculator. So I've already done this out here. I got 0.82146 for the margin of error. If you go straight from here to here, that is fine. I wish they would tell us ahead of time what they wanted us to round this to. I could see the answer in the book. I saw it was tenths. 9.7 to 11.3 is our interval. One thing I've been bad about is not writing down the directions, what we're doing, so I'm going to try to do that more. For number 26, we're trying to find the mean and the margin of error. It is okay to use abbreviations. So to get the mean, I'm just going to take the mean of the 2 ends of the confidence interval, 21.61 plus 30.15. I should say that's going to equal that. Divided by 2. That's going to give me 51.76 divided by 2. That means my sample mean was 25.88. To find my margin of error, I'm just going to find the difference between one of the endpoints and the mean. So that's just going to be like 30.15 minus 25.88, and that is going to give me 4.17, I believe. Oops, check that. That's not 17. It should be 44.27 for my margin of error, and there are my answers. Number 29 is a little twist on things. It is finding the sample size needed, knowing your margin of error, your critical level, and your confidence level, I should say, and your standard deviation. So for number 29 here, and I forgot number 26, you got to do 25 and 27. I did one of the ones between there. 29 here, we get from our margin of error, we can solve that formula for n, and we end up with z critical times sigma over the margin of error in parentheses squared. You can see that on page 304 in your book if you want to take a look at it. And it's just plug it in. So my sample size, and this is an answer we always round up to. So if you get 30.2, you got to round it up to 31. No matter what it is, you always round this number up. That's one of the exceptions for rounding in this class. So we got n equals, parentheses, our z critical value, 0.90. I forgot to look that up. I remember that's on one of the pages in the book in here. That's on page 299, 90%, 1.645. So we're going to have 1.645 times 6.8. And might as well put the square up there. My print didn't write that well. Over e is just going to be 1. They're making it simpler for us. I'm going to pop that in my calculator. And that gives us 125.126596. Now, even though that would normally round down, we don't do that. We always have to round up here to make sure we get the conditions we want. So that's going to go into 126 would have to be our sample size for number 29. Okay, number 37 is just the application of something we did earlier. So we got, our C is 0.9 or 0.90 or 90%. What did they say? 90. They wanted 95%. I didn't write down when I wrote that. 0.95. That's 95%. That means our Z critical value is going to be 1.96. I got that one memorized from looking up that table a couple of times earlier. Our CI is going to equal the mean plus or minus the margin of error, the Z critical value, times the standard deviation over the square root of n. Just going to slap in my numbers here. This is pretty mechanical. 2650 plus or minus 1.96, and then we've got 425 over, what is it, square root of n, square root of 50, and it's time to go to the calculator. Again, I frequently just go straight from this number to this number. I put the margin of error in there, just in case you don't get it right. That's something else you can check your calculations with, but you can go straight to that interval down there. And then we need to interpret that. That is going to go like this. Boy, I write fast. It's amazing how that got on there. So our interpretation here with 95% confidence, you can say the population mean replacement cost is between $2,532.20 and $2,767.80. And that is our final answer on there. The wording, you're pretty much saying that you could, some different orders. The population mean replacement cost is between 2532.20 and 2767.80 with 95% confidence. You can arrange that a little bit differently, but saying pretty much the same thing. You want that 95% confidence, not 95% probability, 95% confidence. Number 39, you're doing the exact same thing. You're just changing one number. The n, the sample size is getting bigger, so your interval should be slightly smaller. Pay attention to that. If it's not smaller, you did something wrong. 45, you got to use your calculator to find your x bar, your sample mean from those numbers there. And use the sigma they give you, not the sigma that comes up on your calculator. Use the 4.3 they give you in the problem. That's our 10 minutes. You have a good day. Aloha.